Hi, everyone. First off, let me just say thank you for coming out to reInvent this year. We appreciate it. And welcome to this talk on building cloud-backed mobile apps. My name is Glenn-Dierkes. I'm a software engineer, and I've been with Amazon for over 10 years. The majority of that time has been with AWS. I've been on a bunch of different service teams, but the last few years I've been with a team called AWS Mobile. And the AWS Mobile team, our goal is to create tools and services that make it easier for mobile developers to build great apps. So what I'm hoping to accomplish in this session is to talk about and demonstrate how cloud services can help you make great apps. And if we think about apps today, we see that there's been an evolution of apps over the past few years, but a lot of apps tend to have one or some or all of these features, and that includes things like social login, allowing your users to log in with an account that they already have from an identity provider. Geotagging data. A lot of devices today have a GPS or some other mechanism by which to get the user's location, and being able to use that data to give them location-relevant information. File and data storage. And then push notifications. I'm sure we all have an app that you get notifications up, a sports update or something like that, on a continual basis. Okay. So if we look at AWS and we look at how does it play within the mobile landscape, there's a couple of things, a couple of services that specifically address the features I just talked about. Now, this doesn't represent everything that AWS has for mobile. This is more of a snapshot and just kind of a range of different things that we offer. And it's specifically more about the things that I'm going to be talking about today in the talk. But there is a service called AWS IAM, or Identity and Access Management, and that can enable social login. Amazon S3, or simple storage service. That's great for file storage, large data storage. Amazon DynamoDB is great for user data. And then Amazon SNS, or simple notification service, can help with mobile push or push notifications. Now, some of the great things about AWS, and if you went to the keynote this morning, you probably heard some of these, is that it's a pick and choose. You don't have to get all of what AWS offers. You can pick and choose what pieces you want to use. So if you just wanted to add push notifications to your app, you can do that by just getting involved with SNS Mobile Push. And you can just leave it at that. But if you wanted to do more and you wanted to enable social login, you could add that as well. So you can pick and choose what pieces of AWS you want to use and what you think will help make your app better. Another great thing is that AWS is worldwide. We have regions, many continents, and lots of different locations, so we can make sure that your data is near to your customers and where you expect them to be using it. And another great feature is that a lot of these services have a free tier. So you can try essentially risk-free these services out, and you can try working with it, coding against it, integrating into your app. And within a certain amount of usage, there's no cost to you. And as also mentioned this morning, it's pay as you go, or it can be on demand. So you only pay for as much as you use. If you decide to stop using the service, you don't pay anymore. Okay. So for this talk, what we did is we put together a demo app that kind of highlights the different features I had mentioned earlier. And it's a pretty simple app, but it's an app that allows users to share geotagged photos with others. So first, I want to just go do a quick demo. But throughout the session, I'm going to be going back to the app, going into a little bit more detail, showing code, and showing specifically how we got certain parts of the app to work. Let's see if I can do this. Okay. All right. So to start off with, I can log in, and I'm prompted with different ways that I can log in. So you can see here I can choose to log in with my Facebook account. Now, I've already authorized Facebook with this app, so now it's logged me in. And so then I can view pictures. So I have no personal pictures, but I do have public pictures. And so I can click to look at a picture. And that's a great public picture right there. I can mark pictures. Let me go back for a second. I can mark pictures as favorite. And then I can see my list of favorite pictures. I can also add pictures. And then I can also view the pictures of, when anytime somebody uploads a picture, it geotags the location they uploaded the picture from, and we can see the different pictures where they are, from on the map. So like I said, that's just a brief overview of the app. And I'll be showing the different parts and how they fit together. Now, one other thing I want to mention is the app I'm showing is, if you haven't noticed already, it's an iOS app. But all of the technology and everything that we have available for Android as well. So this app could be completely written in Android if you wanted to do that as well. So this is the architecture of the app and how it all kind of fits together. So to start with, the client can, using a technology called Web Identity Federation, can connect with identity and access management to then connect to and allow the users to log in with Facebook or Google+ or log in with Amazon. We have it enabled with the S3 Transfer Manager to be able to talk to Amazon S3. And that's for getting the pictures and uploading pictures. To store the favorites, we use the AWS Mobile SDKs, and we'd store that directly into Amazon DynamoDB. And then to get the geo information, what we did is we have actually a geo server that runs and connects, the app connects to, and it uses the Geo Library for Amazon DynamoDB to be able to geotag data and put that data into DynamoDB. So first, let's just talk about Web Identity Federation. All right. So what I'm going to do is I'm going to walk you through the process by which Web Identity Federation works. So first, the mobile client, the user would press, like I showed, I pressed on the login button. So the user would press login, and the mobile client would redirect the user to Facebook or whatever third-party identity provider they chose. And the user would then be asked to authenticate. So in some cases, to log in with, to type in their username and password for Facebook, or in the case, since I had already authenticated, Facebook just said, oh, yeah, I've got his information, he's good to go. So at that point, the identity provider returns an access token. And so the mobile client can take that access token and can send it to Amazon STS, which stands for Security Token Service. And that's a service that's part of IAM, or Identity and Access Management. And what STS is going to do with that token is it's going to go back to the identity provider and validate it to make sure that there was no tampering midstream or anything like that. And once it gets that validation from the identity provider, it can then send back AWS temporary credentials back to the mobile client. Now, if you're familiar with AWS, you understand why we need to get credentials back to the mobile client. Credentials is how you communicate with any of the services that AWS offers. So you need those credentials on the device to be able to interact with them. And if you're new to AWS, that's a piece of information that you'll be quickly familiar with if you start using it. The credentials allow you to sign requests and then communicate with the various services. And so that tells AWS who you are and make sure that we're granting access to the right people to your resources. Now, the other thing that we can do, that STS can do, is it can apply a policy to the credentials. And what the policy object can do is it can limit exactly what rights those credentials have. So for example, if I only want to give the credentials the right to access S3, I can say that's all he has. And I can restrict it further by saying he only has rights to this bucket within S3. And so you can really restrict exactly what the person can do with those credentials. Further, with Web Identity Federation, you can use what's called policy variables. And so what the policy variables can do is they can take the ID that comes from the user that logged in with the third-party identity provider and also put that into it dynamically into the policy. So that way, that allows you for each user to customize exactly what rights they have within your resources, within the policy. And so what it means, you can silo and segregate your users from each other. So you know that one user can't trample upon the data and the usage of another user. So once the credentials are all set up and onto the client, we can now, from the mobile client, access AWS. And so then we can access S3 or DynamoDB or whatever services we want and we need that mobile client or mobile app to have access to. So why would we allow Web Identity Federation, or why would somebody want to use it? And one of the most obvious things is that managing user accounts and passwords is not easy. You have to set up a database. You have to store the passwords securely, and it's a lot of work. And it doesn't enhance your app any better. I don't think anybody's going around, boy, I really love that login or user registration process for the app, right? Nobody's excited about the login process. And users are getting tired of having to create another account that they have to manage and remember a password for. So if you can enable and allow them to use their existing accounts, it makes the app a little easier to work with and get started with. And we support, through Web Identity Federation, some of the major identity providers, Facebook, Google, and Amazon. And like I mentioned, that the whole process allows you to get temporary and restricted credentials onto the device. One of the things that we don't recommend is actually putting the credentials into your mobile application code. It's got a couple of problems. It can be compromised. It's not secure. And then worse yet, if for some reason you needed to change your credentials and you needed to rotate your credentials, you would actually disable the app. It would be difficult to get an update out there, and your users would be locked out for a period of time. So using Web Identity Federation, you can make the changes at any time on the back end, and the users can always get up-to-date credentials. Now, I did pretty much a brief overview of Web Identity Federation, but tomorrow, a colleague of mine, Bob Kinney, he's also on the AWS Mobile team, is going to be doing a session talking about Web Identity Federation and going into great depth. He's actually going to be showing the same app and showing how to turn on another identity provider and going through the steps that it takes to do that. And so that session is tomorrow at the same time, 1:30 to 2:30. But if you can't get to that, if you have another session you want to go to, we have a blog post. And I'm going to be talking more about the blog through the session, and I'll give you the links for that. But there is a blog post that we have that talks about Web Identity Federation and goes into detail about how to set it up and steps you through the process of adding it to your app. Okay. So next, the S3 Transfer Manager. So as the name kind of implies, it's a vehicle for which to communicate and work with Amazon S3. And it provides some higher level functionality. Now we have, as part of the mobile SDKs, we have the direct operations that you can do with S3, but this kind of takes it a step further and tries to make things a little easier, especially for a mobile environment. So with S3, you want to be able to upload and download data. And so, there's lots of apps that are doing, uploading pictures, videos, music, or any large content that you can think of. If you have a game and you want to upload a new level or something into the app, you could use S3 to do that. But what the Transfer Manager is really about is trying to make that very efficient for a mobile environment. As the name implies, right, it's a mobile device. People can be walking around, meaning that they're going in and out of connectivity, which means that their connection can be lost for a period of time. So if you think about, if you have an app that you're trying to get people to upload photos, and let's say it's a 100 megabyte photo or video, and it's 100 megabytes that you're trying to upload, and the person's moving around while he's doing this, and he goes in and out of connectivity, the transfer could be broken, right? And so then he would have to restart, and that's just going to be a pain point for the user. So what the Transfer Manager does is it actually breaks up the upload into parts and sends up the smaller parts one by one. And so that way, if it gets through, let's say, half the parts and then one of the parts fails, it only retries that one part. So it's not reloading or trying to retransmit the entire 100 megabytes. It's only doing a portion of it. And so then it can get that and then continue on the way. And then once it has all the parts done, S3 can automatically put them all together into a single object in the cloud. The same with download. Let's say another user is trying to download that 100 megabyte video. And the same thing, let's say the app crashes or something, he turns off his app accidentally or his phone accidentally during the download. Well, if you were to restart it, traditionally you'd have to restart the entire download process. It's going to be a very painful, action for the user to go through it, especially if it's on Wi-Fi, it might not be so bad for certain files, but if you're on 3G or 4G, it's going to get a little bit more painful. So with the download as well, we keep track of how much we've downloaded. When it restarts, we can start off from where we left off and continue the download and get the rest of the file. We have some other advanced features like pause, resume, and cancel that allow you to programmatically, pause a transfer or resume it later, or just cancel it outright. The other thing is that the transfer manager directly connects to S3. So if you have an app, let's say that allows people to upload videos, if you were to redirect this through your own back end, with videos being larger files, you have to keep a connection open for a longer period of time. Which means you'd have to have, if you have tens of thousands or hundreds of thousands of users, you're going to have a big server fleet in which to handle all those connections. Instead, if you have your app directly connecting to S3, S3 is going to manage all those connections, going to handle all that load for you. You don't have to have a server back end to worry about all of that. So let me just show a little bit what this looks like. Oop, I gotta. Okay. So if I wanted to add a picture, so I can give it a name. I'm gonna make this one private. And up it goes, and that was done using the transfer manager. So I go look at so now you can see that I have that picture now in my personal settings. If I wanted to view a picture, and this picture is actually quite large. I think it's over 10 megabytes. And so you can see it streaming down. And so I can pause it. And so it's going to hold there. And then if I resume it, it's going to continue from where it left off. And so that would be the same if the app had crashed as well. If I said to, hey, start loading this picture again, it would start over from where it left off. And then if I want to dismiss it, I can dismiss it, and that kills the transaction, no more network activity going on. Okay, back. So now, if you wanted to, with our SDKs, we provide the functionality to implement multi-part uploads. If you wanted to do that, this is what a little bit of the code would look like. It's actually a little bit more. It needs 2 helper functions as well. And what that code is doing is actually breaking up the file that I wanted to download into parts, sending the parts one by one, and then telling S3 to put them all together at the end. Now, what's not shown here is I took out, because I don't want to take up too many slides, I took out the error handling as well. And the other thing is that you wouldn't want to do this on the main thread, so the other part that's not here is doing this in the background. You would actually want to do this asynchronously or do it in a background thread, and that's not shown here as well. So there's a lot of code there to make that happen, and that's just for upload. If you wanted to do download, you'd have to do something similar as well. So with the transfer manager, it's a little easier to get started. So first thing you have to do is you have to create a transfer manager, and you have to give it an S3 client from which to work with. And S3, in our client, we give you some different settings you can change. So you give it the S3 client that you want to work with, and then if you want to upload a file, that's it. You give it the file that you want to upload, the bucket name, and the key that you want to store it within S3. That's it. This code, that line of code behind the scenes is automatically breaking it up into parts, sending them one by one, doing all the error handling, and doing it in the background. The same for download. The same thing. The download doesn't use MultiPart upload. It uses what's called a feature of S3 called range gets. And so that's doing it in parts and getting that data. And if it needs to continue, it can start from where it left off. And again, it's a single line of code, all the error handling, everything. And then if you wanted to pause, resume, or cancel any of these transfers, again, it's a single line of code. Now, one thing I haven't mentioned is you can start multiple transfers in parallel. And then you can pause them all or resume them all or cancel them all with a single line. Or you can pause or resume individual transfers. So one thing I do when I start an upload, I can capture the basically the handle to that upload and then pause that directly. I just showed the all case in this fashion. And this is code that actually exists in the app that we have, these lines of code. So you can see in 7 lines of code, I could enable my app to do uploads, downloads, pause them, whatever, with just a few lines of code. And it's all in the background, all with error handling. So now if you wanted to learn more about the Transfer Manager, we have a number of blog posts on our blog that go into detail about different things, how to get it set up, how to work with it. And the Transfer Manager is a part of our SDKs. And if you wanted to download our SDKs, they're available on aws.amazon.com/mobile. And we have it for both iOS and Android. And it's all open source. So if you wanted to take a look at the Transfer Manager code, you can do that. We have our code is available on GitHub, or if you download the SDKs, you get the code with it. So if you wanted to make tweaks or do things differently, you could do that as well. If you want to do something specific to your application, you could do that. So next, I wanted to talk about the Geo Library for Amazon DynamoDB. And so what the Geo Library is, it's actually a Java library, and it's meant to be used within a backend or a middle tier. You don't use it directly on the client application. And what it does is it produces geo hashes that can be used and stored within DynamoDB. And one of the reasons that you want to move some of this logic to a middle tier is when you do a query for location, for geotag data, you're going to get a lot of data back, and you have to figure out what's within the region that you're actually trying to query for. And so you want to do that manipulation in a back end, because if you do it on a client, the client's going to have to send a lot of data back and forth through DynamoDB, and that's going to be taxing and expensive to the client application. So you use the library on a back end. It can do the communication back and forth with DynamoDB. You can then add some additional logic to make sure you filter it for exactly what your needs are, and then send back the smallest amount of data back to the mobile client. And just as an example, right? I mean, if you have an app that's that has to deal with retail or something like that, and you can capture the person's location, from their location, you can give it either what we call a radius query or a circle or a rectangular query that you can then tell them, hey, here are stores within your area relative to your current position. So let me just walk through it again. And so essentially, the mobile client's going to talk to the Geo server, and it's going to make a very specific request to either put geotag data in, or to get some back, or to do a query based on a region. And so the Geo library then has very specific functionality so it makes this easy. To get points, you can call these methods. There's get point, put point, delete point, and then there's 2 types of queries based on a radius. We call it radius. It's a circle. You give it a center, and then you give it a radius, or you give it the 2 endpoints of a rectangle, and it looks for all the points within the database that are within that region. It does a bunch of communication back and forth with DynamoDB, and eventually they figure out what data was within that region. Then the Geo query, you can do any additional logic you want to do, and send the filter data back to the client. So let me just show you that in the app. So pretty straightforward. So what's happening here, and if you remember the first time I showed this, it only had 2 pins on it. Now it has a 3rd because I uploaded that 3rd picture. But essentially, it knows our location is Las Vegas, and I'm doing a radius query here of 5,000 meters. So it's finding all the points that are within the database that are within that region, that circle. So there's the there's the AWS picture that I had uploaded before. So if we look at that. So if we look at that code, so what's actually happening, and this is code, again, that you would be running in a server environment. The first thing you need to do is you need to create a DynamoDB client. And with DynamoDB, you want to specify what region you want to work with. So for this app, we specified US East 1. Then the main interface is called the Geo Data Manager, and there's a manager configuration. And with it, we give it the DynamoDB client that we created, and then the table within DynamoDB that we want to store or retrieve our geotag data. We then feed that into the Geo Data Manager. Now, there's other configuration that we can do. I just went with the defaults. So now, if I wanted to do a query, the first thing I'm doing, since, as I mentioned, I did a radius query. The first thing you have to do is you have to give it the center point, and you give it the latitude and longitude, and then I specify, hey, these are the data points that I want from the database. I want the title of the picture in this case, and the user who uploaded that photo. I put all of that together into a GeoRadius request, and then I just send that to the Geo Data Manager and have it actually execute the request. Now, at this point, it's going to communicate back and forth with DynamoDB to get the points that fall within that region. And so now it's going to return a set of points that were within that region that we just queried for. And so at this point, we can loop through those points. And then for each point, I can extract out the user ID and title, because that's what I told it I wanted to retrieve back. By default, it will return back everything. To be more efficient, I told it to return back the attributes that I wanted. And then at that point, I can do extra filtering. So in this case, what I did is I only allowed a user to see the photos that he actually uploaded. That's the matching of the user ID, or that the photos that are marked as public. You can see those photos as well. So that allows us to filter the data even further, and then I can return that back. And this code actually exists in the server that we have as part of the sample. So again, with the Geo library, it's all open source, and it's available on GitHub. And so if you wanted to customize the logic of how the library works, or you wanted to make changes, you can feel free to do that. And we have a blog series that goes into detail about how the Geo library works, talking about the configuration, how the algorithms actually work to get the geo hashes based on latitude and longitude, and how it all breaks up. And on GitHub, the sample includes not only an iOS app that's just demonstrating doing a location-based app. It also provides a middle tier, a sample tier that you can run in Elastic Beanstalk. So next, I wanted to talk about the mobile SDKs. And here, let me just show you how they're used within the app itself. Oops. So if I go to my favorites, I can see I have two pictures that I've marked as favorite. If I go back here, and I say that I want to add that to the favorite, if I go back, it's been added. And this is communicating with DynamoDB. It's sending that information to DynamoDB. So the way the mobile SDKs work is that they provide access directly from the mobile device to a number of different AWS services, including DynamoDB, S3, SQS, SNS, and a few others. And so you can access those services directly from the client. And what's one nice thing about that is if I have this application on 2 different devices, you can imagine I have this app running on an iPhone and then I have an iPad. If I were to favorite a picture on one device and then go look up my favorites on the other device, it would be in sync. It would be there automatically because it's accessing from a single repository. The other thing is, as I mentioned earlier with the policy objects, DynamoDB has something called fine-grained access control. So you can specify that a user can only access certain rows of a table. So you can have a single DynamoDB table that supports millions or tens of thousands of users. And each user would only be able to see the rows relevant to them. And the SDKs are both available for both iOS and Android. So when using the SDKs, it's pretty much a consistent pattern if you wanted to use them. So first you create the service client. So in this case, if you wanted to talk to DynamoDB, you create a DynamoDB client. S3, you create an S3 client. Then you put together your request. You submit the request to the client itself. And then that's going to give you results, and you would just process those data results. So if we look at this in actual code, so this is here I'm creating the DynamoDB client, and this is the code to actually get the favorites. And if you were to look at the code in the sample, you would see this code. And so then I put together my GET request. So I'm telling it, I want it for this user ID. The data is within a particular DynamoDB table. And I'm telling it to do a consistent read, which means get me the latest data. At that point, I submit it to the client, to DynamoDB. I submit the request. And then it returns back the data, at which point I can pull out the favorites. And that's what's being returned. And at the same time, the same thing is happening for putting data into DynamoDB. So since I have the client already, I don't need to create that again, but I need to put together a put item request. And so again, I specify the same table. I tell it, here's the user ID where I want to store that data for. Here's the list of attributes. Put that all together in the single put item request and submit that to the server. And that's the pattern essentially that's used for any type of service that you want to work with the SDKs. And that's the same for Android as well. Android, you would follow the same essential process. You'd create a client, create a request, submit the request, and process the results. Now, on our blog, we have a number of different posts that go into different things about the SDKs. The blog link that I have here actually talks in detail about DynamoDB, about using the mobile SDKs with DynamoDB. And both SDKs are available, including the code. The code is all on GitHub. So one thing that I can't demonstrate is SNS Mobile Push. You can't receive notifications on a simulator. But we do have that code within the app, and I just wanted to talk about that for a moment. So one of the things that SNS Mobile Push does is it allows you to create, you can register devices individually to receive notifications, and you can create a topic and then subscribe devices to that topic. And what that means is you can subscribe devices across push notification services. So you can subscribe Apple devices, Google devices, and Android and Amazon devices to a single topic. And so when you push to that topic, all of those devices would receive the same notification. So you don't have to write separate logic to push to Apple devices versus Google devices and so on. You can still push individually if you wanted to do that, but this is one nice feature, is that you can push across platforms in a single publish. The other thing is that the mobile push console really simplifies setting it up. If you've done anything with notifications, you know you have to get certificates and keys, and you have to get that from the actual notification provider. You have to set up the keys and certificates, and you have to upload that and set that all up. The mobile push console kind of walks you through that process and simplifies that. So the way it works is, the first thing you have to do is you have to create what's called a platform application. And what this does is it specifies what type of devices that you're going to be supporting, what push notification service you're going to support. You could set this up programmatically, or you can do it through the console. That's what I was talking about before, where you give it the keys and the certificates. And at the end of the day, what you're getting back is you're getting a platform application ARN, or Amazon Resource Name. So then when you want to register a device, and this is code that we actually have in our client, so if we ask the app wanted to say, hey, yes, I'd like to receive notifications, this is the code that would happen. It would put together what's called a platform endpoint request. And it would specify the device token string, which is going to be specific to for Apple has its own way, Android has its own way of doing it. But you would get that token string, you would put that together with specific custom data, whatever you want for the customer, and then you would give it the application, the platform application ARN. You would put that all together in a request, and you would submit that to SNS. And then that would register the device with that platform application. And so then when you publish, that device would receive notifications. And publishing, you can do it through the console, or you can do it through programmatically through any one of our SDKs. And we have a number of SDKs that can support publishing through SNS. If you wanted to learn more about SNS Mobile Push, Jeff Barr had a blog post that talks about how you can engage customers and some of the benefits of the technology, as well as the SNS Mobile Push documentation has a sample app that just shows specifically how to work with SNS Mobile Push. And it walks you through, again, setting it all up, registering a device, publishing to that device, and it shows it for the various, Amazon, Apple, and Google. There's also going to be a session on Friday where a customer, I believe, is going to be talking about his experiences with SNS Mobile Push and going into detail there. So I've been putting up a lot of links, and some of those links have been a little ugly. Not the best links to remember. But if there's one link you're going to walk away with, it's this first one, aws.amazon.com/mobile. This is our mobile development center. And from this page, you can get to all of the other things that I've mentioned throughout this session. You can find the SDKs and how to download them. You can get to API reference documentation for the SDKs. You can get to the GitHub repositories. You can get to our blog. All of that is available through this one link. If you need help with setting up the application or doing any of this, we have a forum that the entire team monitors actively, and we respond to customers all the time on that forum. And it's a community forum, so if you're on the forum and if somebody asks a question that you know the answer to, feel free to answer it. We love it when we see our customers helping other customers. We also monitor Stack Overflow for questions as well. If you wanted to try out the sample that I showed today, all of the code is available on GitHub, and it includes the client application as well as the server app that goes with it. And it has detailed documentation about how to set it all up, all the things that you have to do with AWS, and walk through that step by step to get it all set up and running it in your environment. We also have a bunch of other, I think over 10 samples for each SDK that are also available on GitHub. And we're always adding new samples, trying to make it very easy to get started with the various technologies that we have. And you can see them there. They're all available on GitHub, and they include documentation, again, to walk you through it exactly. And some of the samples have are multi-purpose, not only trying to get you to understand the SDK, but also get you to understand how to work with the service and how it can work best with in a mobile environment. So it's some of the samples are very specific to mobile use cases that you may encounter. So if you wanted to connect with me or the rest of the team, we're going to be in the developer lounge, a lot of the time, and we will have office hours tomorrow and Friday. Like I mentioned throughout the session, we have our mobile blog. I would check that out. We're regularly putting up new content there. And the other thing I'd just like to say about the mobile blog is when we did one version of the Transfer Manager, we got some feedback on it, and the feedback was saying, was asking for, I'd like to pause my transfer. Why don't you guys have a pause functionality and things of that sort? And so we take all of that feedback and we utilize it. And and that's some of the new features. That's how the pause, resume, and cancel came about. It was actually directly from customer feedback. If you go to the blog and you look in the comments section, you will see where customers were asking for some of the functionality that we then implemented and delivered. So feel free to, on our forums or on the blogs, to make comments if you see, something that you need or something that could be done better. Feel free to comment. You could also follow us on Twitter at AWS4Mobile. So that was my session today. So we have time for questions, but if you don't get time to ask your question, or if you don't want to stay or whatnot, you can still find us in the developer lounge or come to our office hours. But the other thing that Amazon values is customer feedback, as I mentioned. So if you can fill out a feedback about this session and what you thought, good or bad, it'll help me become a better presenter and help us direct content that's more specific to what you guys are looking for. So thank you.